Good afternoon, ladies and gentlemen. Today we're going to be looking at our metals, nonmetals, and metalloids notes. Elements that are metals are good conductors of both electricity and heat. Their physical properties state that they have a high luster or are shiny. They are malleable, which means they can be smashed flat. They are ductile, which means they can be twisted and pulled into a wire. And again, are good conductors of electricity and heat. Chemical properties of a metal is that it can corrode or rust. It has varying levels of reactivity with other elements, and it can form an ionic bond. There are specific families or groups on the periodic table that are classified as metals. Remember that a family or group is a vertical column on the periodic table. The first one is known as the Alkali Metals. It's in the first column on the periodic table and has the elements sodium, potassium, and francium. The second family is the alkaline earth metals in the second column, with some examples being calcium and magnesium. The transition metals take place in the middle of the periodic table. There's quite a few of them here, but some of them would be gold, zinc, and nickel. Then we have our lanthanide and actinide series. These are the two rows below the periodic table with things like cesium, lawrencium, europium, uranium, actinium, and plutonium. Nonmetals are defined as poor conductors of electricity and heat. Their physical properties state that they are dull or not shiny. They are brittle, which means they can break easily. And once again, they are poor conductors. Their chemical property is that they are able to form covalent bonds. Families of elements that would be considered nonmetals on the periodic table would be the carbon, nitrogen, and oxygen family in the 14th, 15th, and 16th column. Not all of the elements in this column are going to be considered nonmetals, but we will get to that in a moment. The final two nonmetal families would be the halogens in the 17th column with elements like fluorine, chlorine, bromine, and iodine, and the noble gases to the far right. These are our most stable and our unreactive elements on the periodic table and are made up of elements such as helium, neon, and argon. The final group of elements that we will be discussing today are metalloids. The physical properties of metalloids are shared between both metals and nonmetals, which means they have some of the same characteristics. Typically, metalloids are metallic in appearance, but are brittle like nonmetals, and are only fair conductors of electricity. The chemical properties of metalloids, like the physical properties, are also shared between metals and nonmetals, which means they will have some characteristics of each. There are no specific families or groups for the metalloids. We say they are along the stair-step line on the periodic table. You can see it descending here from the top left, which is boron, down all the way diagonally to polonium. Finally, today we're going to address the two types of bonds that elements can form. The first is an ionic bond. An ionic bond is when an atom of an element is willing to give or take electrons so that its outermost ring is completely filled. This would mean that its valence electrons have reached 2, 8, or 18 in the first, second, or third shell. This means the atom is stable. This type of bond will only happen when a metal atom and a non-metal atom join together. Please note that metal and ionic have the same number of letters, in case you need to remember this for a future test. The second type of bond we will be discussing is a covalent bond. A covalent bond is when two atoms are going to share electrons. You can help remember this by understanding that the root word co means together or to share. This happens between a nonmetal and a nonmetal. Please note that non-metal and covalent have the same number of letters. This is also a useful way to remember that covalent bonds form between two nonmetals when asked on a test.